Today I'm going to be showcasing our new Dagger module for Cerbos and give you a bit of a run through of what Cerbos is, how it works, and basically how Dagger basically enables you to orchestrate all your testing around authorization. By the way, introductions, I'm Axel VA. I'm one of the co-founders of Cerbos, and Cerbos is an open source authorization system for developers to implement fine-grained roles and permissions into their application in days, not months. So authorization, unfortunately, is one of those loaded terms. It sounds very similar to authentication. So just to make sure we're all on the same page, when we talk about authorization, we're talking about what a user can do inside of a system. So authentication is deciding, okay, is this person who they say they are? What is their identity? Your challenge, give me a username, password, get back some sort of identity. And then authorization is the next level of detail, which is, okay, now I know who this person is, what roles they have, what teams, their groups, those sort of things. Now inside the application, what can they actually do? And the way this is kind of traditionally implemented is inside your application code. I've been guilty of this. I'm sure many of you have written code like this before, but essentially inside of your request handler, you have a request coming in. You go off to your database to go and fetch whatever resource that user is trying to access. You know who that user is because they're authenticated. And then you have some sort of like if-else statement, like the one you can see in this box here. So you're doing things like, if the user's email address includes our company domain, then they are an admin. Or if this user is part of a certain package, they should be able to call particular APIs or have certain amount of credits, they can hit certain endpoints, or they're part of maybe a different group or team. And this kind of authorization logic, this spaghetti code we call it, starts off small and manageable, but very quickly grows out of control and gets quite complicated. So what Cerbos is an externalized authorization solution. So in terms of how this works is if you were to kind of build an application, and this diagram is kind of running through a typical request cycle, you would have some client application. So a web app, mobile app, even some API that maybe you're pushing out to the world. People start interacting with the application and that sends requests to your backend. So you're probably going to go through some sort of API gateway. That gateway might go on and then redirect the user to your identity provider, challenge them to log in, get some sort of identity. But eventually, somewhere inside of your infrastructure, it's going to hit a service that's deployed. So it might be a container in your Kubernetes cluster somewhere. It might be running as a Lambda function. It might be running as something on bare metal machine somewhere. But ultimately, a request is going to hit some server inside of that system. So that application now knows who the user is. And also based on the actual request coming in, they now know, the application knows what to do with it. So they're trying to view a report, they're trying to edit an expense, they're trying to post a comment, they're trying to download a bit of media, the application specific details. And based on that request, the application then go off to the database to go and retrieve whatever resource that user is trying to access. And then this is where traditionally that if-else case switch style logic would be implemented. So with Cerbos, the idea is rather than hard coding all that logic, which gets kind of brittle, you have to start replicating across your code base. If you go to like different microservices or different languages, you have to replicate this authorization logic into multiple languages potentially, and things get kind of cumbersome to change and manage and update. The externalized approach is different. So you take all that business logic and you take it out and put it into a standardized service or a centralized service that runs inside of your system. So in Cerbos, you define all your business logic as policy. And those policies define, here are the different resource types in my system, here are the different actions that can be done against them, and here are the conditions under which those actions should be allowed. So it could be as simple as checking whether someone has a particular role, or it could be as fine-grained as attribute-based access controls, where you're looking at individual attributes about either the user, principal, or the resource they're trying to access. So the kind of base case for attribute-based access control is you only want a owner of a particular resource or a document to be able to, say, delete that document. So now you have a policy that says, okay, the delete action should only be allowed if the person is, say, a manager role and the owner ID attribute of the resource is equal to the ID of the person making the request. Thus, they are the owner of it. Thus, the action should be allowed. So you define all that as policy, and Cerbos, they're YAML files. They're a static asset. We have CI tooling, which is where the Dagger module we've published comes in. But ultimately, those policies get loaded into a policy decision point, which is the little Cerbos box here. And you can run these across your infrastructure. If you're doing Kubernetes, you run it as a sidecar. You can just run it as another service inside of your stack. And then now in your application code, at the point where you want to figure out, okay, should this action be allowed or not, rather than having everything hard-coded, you just make an API call out to that service that's running alongside your application. And you simply say, I have this user trying to do this action on this resource. That Cerbos container then evaluates the policies that are loaded in, comes up with a decision, typically an allow or deny, but it can also be a conditional response, creates an audit log of that decision. So at this time, this user tried to do this action on this resource, and it was either allowed or denied by this particular policy, and then simply returns back to the application the decision. So now in your application code, the whole complex authorization logic you had before is now a simple if statement. If Cerbos says allow, do the action. If not, return some sort of error message to the user. So what this now means is two things. One is you can evolve and change your authorization logic outside your application code. And two, you now have a strong audit log of every decision and action that a user has done inside of your application, because all the checks are going through a standardized decision point. So architecturally, that's kind of how it all works. And we have a sort of a dummy application, which I'm going to Daggerify. Is that the phrase you used? Daggerify? Dagger? Something like that. So it's like a very typical SaaS application. I'm a user. I've Daggerized. There we go. I've got some different roles. I'm actually going to swap between some different users, and you'll kind of see if I go and look at this like an expenses tracking application, if I look at this particular resource, if there's few different user roles, you're going to see the UI is actually going to change based on what actions I can actually do. And that's all defined by Cerbos policy. So this application is built as a React front end, a Node.js backend, and then we have our Cerbos policies. To give you an idea of what Cerbos policy looks like, we have our resource. This is our expense resource. We're defining the different actions that can be done against it, and then we're checking for whether this action should be as a role, as it should be allowed based on a particular role, or we actually start looking at whether actions should be allowed based on conditions of attributes and such. So the nice thing with Cerbos is you can now also write tests against these. So because this logic is now statically defined, you can now write all your test cases of this action should be allowed or denied against certain test criteria. And this is where our Dagger module comes in. So we published a version of our Dagger module, and it has two main functionalities. One is what we call the compile, and the other one is what we call the server. So the compile method, if I run it, we just point it to where our policies are, and it goes through and actually goes and compiles our policies and runs any test. And in this case, it will pass. We can see, the tests have passed. If I go and then update some of my logic, so let's say we have a rule that says only finance team can approve transactions up to 10,000. We're going to change that to 20,000. I can go and run that again, and it goes off, runs, and now this time it's going to, unsurprisingly, fail. So we're actually exercising and running the Cerbos test suite as a Dagger function, and that's just using the Cerbos compile method. And we can go and look at my definition for that. Let's have this Cerbos test function. It's very simple. We just pull in the Cerbos module. We then run the compile method, pointing it at where our policy directory is, and then it runs. For the second use case, when we want to kind of build our demo application that you just saw, it's a kind of a multi-step build. First off, we go and create our server instance. So this is just a Node application. Wrong one. We get a Node application, we install some dependencies, and then we do an npm and install at the end. So now we have that container with the Node app installed. But our Node application also has some end-to-end tests built in. So we actually are doing unit testing here. We're using TypeScript jest to do some tests. And for these tests to pass, we actually need to run a Cerbos instance. And the application during the test is calling against your real Cerbos instance to check whether decisions should be allowed or not. So the second capability of our module is we have the server. So during our CI pipeline, as our Dagger run, we spin up a Cerbos instance. We point it to the directory again with all our policies are in, which would have been passed at this point, and then it starts up and runs a server. So now inside of our Dagger definition, we also then run our tests. So we start up our Cerbos instance, we point it to where those policies are stored, we then attach a binding to it, and then we execute the npm run test against our server instance. And now we're actually calling to that real instance of Cerbos that's running as part of our CI job to actually go and check and run the policies and make sure the application can call out properly as it should from its own inbuilt tests. And and off it goes. So that's now built. If I go and run my test as we did before, obviously we had a failure. If I then go and fix that test, which I have a test case here. I won't go into too many details for time reasons, but I'm basically going to allow that test to pass. And now I'm going to go and run Dagger cool my build. And here I'm giving it, okay, here's my client app, here's my server app, here are my policies. That's going to go off. It's going to go compile the policies as it runs through. And essentially build the application and pull up your nice Traces UI, which I only found last night when I was building this demo. It's very fancy and I really like it. It goes through, it compiles the policies, it then kicks off the container, it does the build, does the npm install, it then does the actual build, then goes and starts up the Cerbos service, attaches it before it runs the tests. It then goes and runs the test. As it then goes through and executes those tests, and we can see from the logs that are coming out here, these gRPC messages, they're actually coming from that Cerbos service that's running alongside it. And at the end, it goes and builds the actual container and publishes it. So here we've taken an application, we've containerized it, we're building it using Dagger. We've run that Cerbos module to both test the policies, but then also exercise the end-to-end tests that require Cerbos service running. And then at the end, in this case, publishing the application. So that's the short version of how the Cerbos Dagger module works. We published it a couple months ago. Jeremy, we bumped into each other at one of the conferences in Seattle, and I think there and then we sat down and you helped me write that first version of the module, and that's pretty much exactly what we shipped. It's up on Daggerverse. You can go and get it and get up and running, and you can find out more about Cerbos at cerbos.dev or over on github.com/Cerbos.